Hey guys, welcome to Module 4. This is Lesson 1. We're going to go over decimals, fractions, and some order of operations. Now we can use a calculator, so you might want to get a calculator handy because we will need that for part of this lesson here. Okay, so the first thing we need to know is the meaning of a place value for a decimal number and write decimals into words. So, you have your decimal point. Anything to the left is a whole number. Anything to the right is your decimal portion. So, when you have a number, let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, and 2. When you have this huge number right here, anything that is directly to the left of this is your ones place. Then you have your tens, hundreds, thousands, 10,000s, and 100,000. So for the most part, we're pretty familiar with our whole number place values. These are the names of our decimal places. So when you have one decimal place, that's the tenths. When you have two decimal places, that's the hundredths. 3 decimal places is the thousandths. Then you have 10,000s and 100,000. Your little helpful hint here says, notice that anything to the left of your decimal place ends just in an S, but anything in the THS is your decimal. Decimal ends and the THS. So first thing we're going to do is write your decimal in words. So here we have 0.7. So the first thing you're going to do is write your whole number. Well, I don't have a whole number, so I don't need to put 0. You're going to write and for a decimal point. Because I don't have a whole number, I don't need that. But then we need to write our decimal part in words as though it were a whole number followed by the place value of the last digit. So this, we have a 7, so we'll write out 7. And then it's only one decimal place back. One decimal place back is the tenths. So this is 7 tenths. On B, write out your whole number first. So my whole number here is 50. Write and for your decimal point. So I've got 50 and. And then write out the decimal part as if it was a whole number. So that is 82, but this is 2 places back behind the decimal. 2 places back is the hundredths, so 82 hundredths. And on C, write the whole number. So we've got 21. Write and for the decimal. Write out the decimal part as if it was a whole number. So we've got 93. And this is 1, 2, 3 places back, right? From the decimal, 1, 2, 3 places back. So 1, 2, 3 is the thousandth. All right, now let's go opposite. Now they're going to write this in word form. We need to put this into standard form. Standard form is your number. So you've got 48. Your and is your decimal. And then 26 hundredth. Now be careful with these decimal places. Notice when I put my 26, ask yourself, is that in the hundredths place? Is it 1, 2 decimal places back? Yes, it is. So this is my answer. When I turn the page, watch this. Now I've got 6 and, so that's 6 and, so 6 in my decimal. This one is 95 thousandth. So if I put just that 95 here, is this in the thousandth? This is supposed to be a TH here. Is that in the thousandths place? Well, this is the tenths and hundredths. It's not in the thousandth. So this right here is not my correct answer. That's 95 hundredth. Because I want this in the thousandth, means 3 decimal places back, we're going to go 6.095. Now, this digit, that 5, is now in the hundredths place. Okay, and that's what this little helpful hint right here is saying. If you need to, make sure, it says make sure the last digit is in the correct place by inserting zeros if necessary. Okay, next part of this lesson, you're going to have like a lot of little parts with this. And so they all go together, but we're going to be kind of moving along to a different thing quite often. Now I need to compare decimals. It says compare digits in the same places from left to right. When 2 digits are not equal, the number with the larger digit is the larger decimal. Again, if necessary, insert zeros after the last digit to the right of the decimal to continue comparing. So here, we've got a 3 and a 3. Those are both equal, so move on to the next one. Now I have a 6 or a 7 and a 6. Which one is bigger? The 7 is bigger than the 6. So we need this symbol here, my greater than symbol. Okay, remember, treat this as a Pac-Man. Your Pac-Man wants to eat the bigger number. So it needs to eat the 7. Here, don't look at this as a number. Don't look at that as 52 and 236. Compare your first number to the first number. Which one is bigger, a 0 or a 2? That 2 is going to be bigger, so this one's going the other way. And again, don't look at this as a 208 and just a 28. Notice you have 3 numbers here and only 2 numbers here. So if you need to, add that 0. So is 208 bigger than 280 or is 280 bigger? And again, compare each number. You've got a 2 and you've got a 2. Those are both equal. So then we have a 0 and an 8. Well, which one's bigger? This 8 is bigger. So it's going this way. Eat the bigger number. Okay, and this right here is exactly what this helpful hint is talking about. More specifically here. It says for any decimal, writing 0 after the last digit to the right of the decimal place does not change that value. So 7.6 is the same as 7.60, which is the same as 7.600. It does not matter what that is. Same with whole numbers. 25 is the same as 25.0, which is the same as 25.00. Doesn't matter how many zeros you add on to it, those are all going to be the same forever. Changing again. Now we're rounding your decimal place. When you want to round, you have some instructions here. I almost think those instructions are confusing. That comes from the book, but I almost think they make it too hard. When you're rounding to the nearest tenth, tenth means 1 decimal. So, go to that very first decimal. That 2 is in the tenths place. We're trying to figure out, is it 736.2 or is it 736.3? Okay, I'm just trying to figure out what that digit is. Is it staying the same or is it going up? So, after you figure out what we want to round to, you have to look at this one behind it. So I'm looking at 3. If this digit is 5 or greater, you need to add 1 to the digit. So that would make that 2 go up. However, like in this case, if the digit is less than 5, drop all the digits to the right of the given place. So because this 3 is not 5 or more, that 2 stays the same, and now I'm just cutting off all those other numbers here. Okay, same thing with all of these. I'm rounding to the 10th, so it's 1 behind the decimal. Look at the one behind it. That 8 is going to make that 7 go up. So now this is going to be 482.8. Okay, again, that 7's going up because behind that 7 is an 8, and that's 5 or greater. Same thing here. I'm wanting to round to 1 decimal, which is that 6, so look at the one behind. That 5 is there. That 5 or greater, we're going to add 1 to it. So this is going to become 0.7. Okay, in which, by the way, that's the same as just 0.7. Now, D, this is when it gets a little complicated. On D, rounding to 1 decimal, which is the 9, look at the one behind it. That 6 makes that 9 go up. Well, what does a 9 go up to? Usually goes up to a 10, right? So now, because this 9 has nowhere to go, this 2 now needs to now go up. So this becomes 33. So because the 9 has nowhere to go up, it makes this one go up 2, and it makes that technically go up to a 0. If you're thinking of a 10, that would be the same as 33.0. We don't really need that 0.0. Okay, that's the exact same thing as just 33. So 33 is a little bit better of the 2, but those are the exact same thing. Now, on example 5, we are still rounding, but now I'm rounding to the nearest hundredth, which means 2 decimals. So, go to the second decimal, which is on A, this 6. Look at the one behind it. That 5, because it's 5 or greater, means that means the 6 needs to go up. So I've got 5.864, nothing in front changes. Then that 6 goes up to a 7 because of that 5. Same thing on B. 2 is in the hundredths place. It's 2 places behind the decimal. So look at the one behind it. That digit is less than 5, so that 2 is going to stay the same. So this becomes 6.12. C, 2 decimal places. So I'm looking at this 9. I'm wanting to round to the 9th, to where that 9 is. So look at the 7. That 7 is 5 or greater, so it means we need to add 1. So those 9s become tricky when we're rounding those up. Now almost think of that as not just a 9, but a 69. What is 1 up from 69? That's going to be 70. So that is the same as 59.70, or a little bit better, just 59.7. Okay, and then D is the same thing, but notice you have a little money sign here. Rounding to the hundredths is the same as rounding to the nearest cent. Nearest cent means 2 decimal places. So if something tells you to round to the nearest cent, that means hundredths place. So 4 is in the hundredths place. Look at the one behind it. Does that 2 make that 4 stay or go up? It's going to stay. So we got 17.94. $17.94. Okay, next objective. We need to write fractions as decimals. So this is a little bit harder to do and show you, since I don't have a calculator to show you this with. When you put this in, all you're doing in your calculator is dividing the numerator by the denominator. So in your calculator, and you can do this on your phone calculator, but you're going to be able to use calculators on the test, you're just going to do 1 divide by 4. That's all a fraction is, right? It means division. That's what that bar right there means. So if you put in your calculator 1 divided by 4, you'll get 0.25. Okay, same thing here. In your calculator, -9 divided by 40, and you're going to get -0.225. You're writing every digit that you see on the calculator. Okay, and so on that one, we did -9 divided by 40 in our calculator. C, do 8 divided by 9. Now, this one, when you put in your calculator, you get 0.8888, and I don't know how many 8s there are, but you'll have all these 8s and then a random 9 at the very end. This means that this just keeps repeating and repeating and repeating, and the only reason that this one is a 9 is because anywhere you cut this off, if I want to round to this decimal here, you look at this 8 and it makes this 8 go up to a 9. So they're just rounding. So really, it's just that 8 is just going to keep repeating and repeating and repeating. When you have something like this, to shorthand this, you can put 0.8 with this bar up at the top. That bar means that that 8 keeps repeating forever, but I don't have to keep writing 8s forever. Okay, so that bar just means that 8's never going to stop repeating. Now notice on this one, you all have proper fractions, meaning that this numerator is less than the denominator. Now on D, we have an improper fraction. An improper fraction, since that 11 is bigger. So that means I am going to get some kind of whole number right here. We had 0 point something, now I'm going to have a whole number. So in your calculator, what is -11 divided by 4? And you should get -2.75. Okay, now that we know how to convert fractions to decimals, now on this next page, I can compare fractions to decimals. So, rewrite these. In your calculator, if you do 1 divided by 8, this as a decimal is 0.125. So I'm going to bring this one down. We got 0.12. So compare these. Now don't compare 125 to just a 12. You've got 3 decimal places here. So let's make this one have 3 decimal places, which means I'm just going to add a 0 to the end here. So now compare. I've got a 1 and I've got a 1. So those are the equal. Those are the same. We've got 2 and we've got 2. So those are the same. But here I've got a 5 and I've got a 0. Which one is bigger? That 5 is bigger. So we're going to have the greater than symbol. Same thing on B. 1 divided by 5 gives me 0.2. Here I have a 0.25. Again, don't compare a 0.2 to a 0.25. If I've got 2 decimals here, I need 2 decimals here, which means I'm adding in a 0. So now compare digit to digit. So I've got 2 and I've got 2, so those are the same. And now I've got a 0 and another 5. This 5 is bigger, which means my symbol's going this way. On C, in your calculator, we're doing 7 divided by 9. When you do 7 divided by 9, you get 0.7 repeating. So these ones are actually equal. All right, now order of operations. We've done order of operations before, but we've done these with whole numbers and integers. Now I'm doing these with whole numbers, integers, and decimals. So we are using our please excuse my dear Aunt Sally. So on this one, this is again a hard one to show you because I can't really show you what we're doing in a calculator. But on A here, when I use my please excuse my dear Aunt Sally, I have no parentheses. Parentheses is more of like 4 plus 6 in parentheses, so you're combining what's in those parentheses. So I don't really have any parentheses in this problem. But I do have exponents. So in your calculator, you need to put this in. I don't have a calculator to show you this, okay? But when you put this in, you have to put this in with parentheses. When you put this in with parentheses, you're going to get a positive 1.69. If you put that in as negative 1.3 squared with no parentheses, you will get a negative 1.69. It's going to change your answer. So those parentheses make a difference. Now when I put this in parentheses, now that means negative 1.3 times negative 1.3, and that gives me a positive 169, or 1.69. Okay, so you have to put that in with parentheses. It makes a difference. So bring down your plus 2.4, and now just add those together. And I get 4.09. Okay, B, use your order of operations. So we've got please excuse my dear Aunt Sally. First thing we need to do, we have no parentheses again, so we're going to start right here with those exponents. So put this in your calculator. Now parentheses aren't as important on this one because it's not negative, but it's not a bad habit just to always do that. So I'm going to get 5.68 plus 0.9 squared is a 0.81, and then divide by 100. Now my order of operations tells me to divide. So I'm going to divide this. And by the way, this is all over 0.2, right? So don't forget that bottom part of that fraction. That was my bad. Okay, so now divide. So 0.81 divided by 100 makes us 5.68 plus 0.0081, and that's all over 0.2. Now I need to add on the top. So let's add these together. When I add those together, we get 5.6881 all over 0.2. And then now last step, just divide by 0.2. And my final answer here is 28.4405. That's my final answer. All right, last page here, I think. Yes, okay. We're finding the area of the figures. So, area of a triangle anytime you're given a triangle, you need to use the formula of A equals 1/2 base times height. Now, a lot of people hate that 1/2, right? You hate fractions. You just can't do them. So, in your calculator, or maybe you memorize this one. This is the one that's not too bad to memorize. 1 divided by 2 gives me a 0.5. So I can rewrite this formula as 0.5 base times height. Those two formulas are the exact same thing. Typically, we like decimals more than fractions, even though we still don't like decimals. So if I'm using this formula here, now just plug everything in. So I've got 0.5 times my base of my triangle is at 5.6 times the height of my triangle, which is 3. So put all of that in your calculator just the way it is. 0.5 times 5.6 times 3. And we're going to get 8.4. Now don't forget, with area and perimeter for that matter, but for area, we need units. So 8.4 what? We've got feet as my unit, and because I am finding area, it is squared. Now that I have over here an area of a rectangle, use the formula we've been using this whole class of area equals length times width. So your length is this 1.2, and then your width is the 7.8. Now, just like before when I changed this fraction to a decimal, you could technically do that. In your calculator, if you do 7 divided by 8, you get 0.875. And so you could plug that in here instead. But your calculator does do fractions. If you look on your calculator, you'll see an ABC button. So to put this into your calculator, you would do 1.2 times, I'm not going to have enough room right there. I'm going to do this sort of sideways. You would put this in by 1.2 times 7, hit your ABC button, and then 8. When you put this portion in here, you get that 7/8. Either way, if you put this in as a fraction or a decimal, you're going to get the exact same answer. And my area here is going to be 1.05. So then we need units. My units are miles, and because it is area, we're going to square that. And then last problem here, we're going to evaluate. We've been doing this since the beginning of this class. Evaluate means get to a single number. So we got negative x plus 5 if x equals 3.8. Get kind of used to when you substitute in things to put these in parentheses. It makes a difference when you're plugging in negatives. So I've got negative 2 times 3.8 plus 5. So again, put that in exactly the way it looks. Negative 2 times 3.8 plus 5. And I get negative 2.6. You can do this part by part if you want to. You can do negative 2 times 3.8. Hit enter, write it down, then add 5. But you got a calculator, just put it on your calculator. And then on B, y squared, if y equals negative 3.2. This is where those parentheses really come important. So I got my y squared, my y is negative 3.2. So negative 3.2, and then square it. Put this in your calculator exactly the way it looks. And I get a positive 5.29. If you don't put that in parentheses and you just get negative and you put negative 2.3 squared, either you write it on your paper this way, or more importantly, you put it in your calculator this way, you're going to get a negative 5.29, and that, folks, is wrong. So you've got to make sure you put those parentheses. That parenthesis there means I've got negative 2.3 times negative 2.3, and those two negatives make that positive, what your answer is. All right, that's all I've got for this lesson. Let me know if you guys have any questions, and again, pause this video, rewind it as you need to.